Okay, we are discussing about average speed, instantaneous speed. Instantaneous speed is the speed at that instant of time. The speed shown by the speedometer is the instantaneous speed. Okay. Instantaneous speed is written like this. Already I gave you this. Instantaneous speed is ds by dt. Okay. Speed at that instant of time. I have given the difference between average speed and instantaneous speed. Average speed is change in distance by distance traveled by total time. Instantaneous speed means at that instant of time what is the speed. Okay. Similarly, we have average velocity and instantaneous velocity. Average velocity is change in displacement divided by time. Okay. And what is this average instantaneous velocity? Velocity means you have to keep the bar over its head. Velocity is vector. Okay, this I will write it as ds bar by dt. Okay. Up to this I have given you the notes now. Average velocity is total displacement by total time. What is instantaneous velocity? Velocity at that particular instant of time. Okay. I think up to this I have given you the notes. We'll go further into this topic. This I have given now. What is this average velocity? Total displacement by total time. Okay. I'm just erasing this. Displacement is different from distance traveled, no? And you remember that displacement is always less than or equal to distance. When it will be displacement will be equal to distance, I will unmute you. If I ask a question, I should get some response. No? 1 minute. Okay, 1 minute. So you can unmute yourself if you know the answer. So when the distance is equal to, when the displacement is equal to distance, if we are going in a straight line path, distance is equal to what? Displacement, okay? So their average speed and average velocity is same. When a vehicle is going in a straight line path, or when any body is going in a straight line path. Okay. So we'll go with the definition. We'll go much more depth with this average speed concept. What I told you, this average speed as total distance by total time. Okay. And for example, there is a vehicle coming from some Vijayawada to here. So you booked something in Flipkart or Amazon, okay? And he has travelled first S1 distance and took some rest. Next S2 distance, like that he travelled all these distances, like divided by time, total time I will write like this, T1 plus T2 plus T3. Okay, this is total distance by total time is nothing but average speed. Okay, if S1 S2 are the distances traveled before the what do you say, before the courier reaches your house, and in S1 distance he traveled with the speed v1 and S2 distance he traveled with the speed v2. Now what is the average speed? Average speed is S1 plus S2 divided by time. Time is S1 by V1 plus S2 by V2. Like this we can write. Time is distance by speed only. No? Okay, in this we got a special case. So that is a special case. Special cases we will write. If S1 is equal to S2. So I will say like this, first half distance he covered with the speed v1 and second half distance he covered with the speed v2. And I will write like this, average speed is, let this be S. Average speed is 2S divided by S by v1 plus S by v2. So first half the distance he covered with the speed, like this we can tell. First half the distance he covered with the speed v1 and second half the distance he covered with the speed v2. So instead of S1 plus S2 I wrote 2S, okay. So S, if you take common you can cancel that, and the LCM, after taking LCM you will get it like this, 2v1 v2 by v1 plus v2. This is the first special case, or you can write like this, 2 by v average is equal to 1 by v1 plus 1 by v2. If the entire distance is divided into 3 parts, this is the original formula, this you have to remember. These are just the special cases, okay. Total distance by total time. Average velocity means total displacement by total time, okay. And there you have to put bar over the head, S1 bar plus S2 bar. Means this is S1 bar, this is S2 bar, this is S3 bar. If I add these 3, I will get this vector. Okay, this is S1 bar plus S2 bar plus S3 bar. I should not add like this, as in distance. I have to remember vectors. Displacement is vector, na? Okay, this is the resultant. Polygon law of vectors. Okay. Displacement, total displacement by total time, okay. If the total distance is 3s and each s distance he is traveling with speed v1, then I will write it here. Okay, if each s distance is covered with the speeds v1, v2 and v3. v1, v2 and v3. Then I will write like this, 3 by v average is equal to 1 by v1 plus 1 by, this is called harmonic mean. You can remember the formula, na? Okay. If the entire distance is divided into 4 equal parts and each part is covered with v1, v2, v3, v4, then what you have to write, v by 4 v average, 4 by v average is 1 by v1 plus 1 by v2 plus 1 by v3 plus 1 by v4. This is harmonic mean, okay. Just note down. Special case 2 also we will go. Second special case. What do you say about the paper, sir? Is it difficult? You answered, na? Right. So before attempting any paper, your your practice is a must. Okay. So at least 1 hour you practice physics daily. Okay. This I will erase, and we'll go for the special case 2. This is over this and this. So in the special case 2, I'm just erasing this, right? And in the second special case, we divide the entire time into equal parts. For example, 2 hours is the entire journey. First 1 hour we traveled with the speed v1. Okay, we are coming to the college, and how we can come, sir? There is corona around us, so that is an invisible thing. Right. But for example, you are coming to college, and you can come to college in 10 minutes if you travel with the speed 10 kilometers per hour. Okay, 10 minutes it is taking. And first, for example, there is a traffic over there. You travel with 5. Next half time you have to travel with more speed. More speed means speed thrills, but it will make us fall on the road. Many youngsters we will be seeing on the roads. If they get bike, the sky is the limit for them. Okay, but it is dangerous for them as well as for others also. Okay, right. So first half time we traveled with v1 speed, and second half time we traveled with v2 speed. Then what is the special case 2 we are writing now? So second special case. So entire time is divided into 2 equal intervals. First t seconds or first t minutes, whatever it is, body traveled with v1 speed, and next t seconds body traveled with v2 speed. And what is average speed? So I have total distance by total time. Speed into time is distance only, na? Total time means 2t you have to take. So this is, you are getting arithmetic mean. What you are getting? Arithmetic mean. Previously you got harmonic mean. Okay. And if the entire time is divided into 3 time intervals, 3 equal time intervals, then if 3 equal time intervals, and speeds are v1, v2 and v3. What is the average speed? V average. Just arithmetic mean, okay? v1 plus v2 plus v3 by 3. Note down this. Previously it is 2 by v average is 1 by v1 plus 1 by v2. 3 by v average is equal to 1 by v1 plus previously. So there total distance is divided into 3 equal parts. Here total time is divided into 3 equal parts. Okay. So time is a very strange thing. Finally it will win the race. What do you say? Time will not stop for us or for anybody. Just I'm erasing this. Oh. You understood the second case, no? So these two are the cases in this average speed. And average speed and average velocity is same when the body is traveling in straight line path. Okay, because displacement is same as distance. Okay. Right, I'll just we'll do some problems on this. So I may not give the direct formula based question, so I'll just make it twist, small twist I will make. Okay, so that is the question. A body travels 2/3 of the distance. 2/3 of total distance with speed 20 km per hour. What may be the speed of a bicycle in the fast tell. What may be the speed of this 20 km per hour? We can go if we pedal it with more force. Okay, 20 kilometers per hour. Even a bike also can go with this. And next one third of the total distance with a speed 40 kilometer per hour. With a speed, what is the average speed in the entire journey? With a speed 40 kmph. What is the average speed for the entire journey? What is the average speed? Okay, that is the question. I have not given any direct formula question. I will write like this. V average is 2s by 3 plus s by 3, total distance by total time. Total time is distance by speed only, na? Speed in 20 plus s by 3 divided by 40. Okay, this is the answer, okay? Distance by speed is nothing but time. What is the average speed? Total distance by, what is the formula? Total distance by total time. With speed 20, he travelled a distance 2s by 3. And with speed 40, he travelled a distance s by 3. So, in the numerator we are getting s. And in the denominator also s you can take common. 3 also you can take common. And this is 2 by 20. 2 by 20 is 1 by 10 plus 1 by 40. Yes, got cancelled here. And V average is 3 will go up. What is the LCM here? 40 is the LCM. 4 plus 1. And this 40 will go up. Okay. This goes how many times? 8 times. 24 kmph is the average speed. Note down this. So maybe your father, if he leaves from your house to an office, so it's an emergency kind. Okay, for example, he is working with Navy. It's an emergency thing and they have to attend the office. Instead of this, what is that, corona? Emergency services are there. There are some emergency services. So they have to attend. Okay, you just find what is the average speed of the vehicle of your father. You have to just see the things around. That is important. You should not lose the interest in physics. You calculate the average speed. You ask your father how much time it is taking to office, and kilometers also. Kilometers you can get in Google, na? How much distance? Google Maps, okay. So you find, so see the things around and just calculate some easy things, okay. And you ask him what is the maximum speed he has gone in the vehicle. Maximum speed at that particular instant. That will be the instantaneous speed at that instant, okay. Right. Just I am erasing this. Okay. It's over.
Sir, 1 second, explain, sir.
This one, it is average speed. What is the formula? Total distance by total time. Here I am taking S is the total distance. S is the total distance. So first 2/3 distance he is covering with a speed 20. And speed time, what is that? Total distance by total time. And time is nothing but distance by speed. What is speed? Speed is distance by time. And what is time then? Time is distance divided by speed. Okay, what is that? 2/3 distance. 2s by 3 divided by 20. That is the time taken, initial time taken for the initial journey, 2/3 journey. And next 1/3 journey he travelled with the speed 40, and s by 3 divided by 40. Okay, this 3 suddenly it will go up. A by b divided by c by d is, you know this na, a by b divided by c by d. A into d divided by b into c. You can write like this. So this 3 will go up. And what is the LCM here? LCM is 40. Again a by b. A by b divided by c by d. Now you should not take like that. This you have to take 3 by 1. A by b is 1. B is 1. This is c and this is d. D will go up, na? 40 will go up. Okay, remaining thing is 5 in the denominator. Total distance by total time. 20 kilometers per hour, what is the time taken? 2s by 3 divided by 20. With 40 kmph, what is the distance covered? S by 3 divided by 40, okay? Yes, I have taken common and I cancelled this S. This is S only, na? Rendu combine chesthe S kada vachedi. Okay, and S I have cancelled, and then I took the LCM. And simple mathematics is this, okay? Next, I am erasing this. So, if formula based questions are asked, then also you can do, na? Previous case 1, case 2 I have given, na? Okay, this I will erase. So another twisting question I will give, okay? But original formula will never change. Total distance by total time, that will never change, okay? I think you have the weekend syllabus up to motion under gravity, na? Motion under gravity. No problem, huh? We'll go slowly. At the ending, we will accelerate. It's not like that, na? Constant speed I have to maintain. Okay. Right. Total distance is some 2s. There is a total distance. We are going to railway station. But this corona is not making us to go, okay? For example, S, total distance is 2s. Total distance is 2s. And for half the distance, we travel with speed v1. and second half the distance we covered with speed v2 and v3. Two speeds we maintained here, and for t time I maintained v2 speed, and another t time I maintained a speed v3. Okay, second half of the journey I divided into two equal intervals of time. Two equal intervals of time. Now what is the average speed? This is the question. What is the average speed? So that is the question, okay? So tell me the formula. Total distance by total time. Time, what is this time here? S by V1, na? Here, from here to here, time taken is S by V1. Plus, here what is the time taken? Here the distance traveled is S1. Na? What is the total distance traveled here? S, na? Second half of the journey. S, you can write it like this: V2 into T plus V3 into T. So this is the total distance, second half distance. Velocity, speed into time is nothing but distance. And what is T then? T is nothing but S divided by V2 plus V3. Okay, that is it. But here I have to write 2T. Why I have to write 2T? Two time intervals, not two equal time intervals. Already I calculated T here, I will substitute it here. So 2S divided by S by V1 plus 2T. T means S by V2 plus V3. Okay. Now you take S as common. 2S divided by S you take outside. 1 by V1 plus 2 by V2 plus V3. S is cancelled here. Okay. And we have to take the LCM here. What is the LCM? V1 plus V2. First you write up to this. And if V1, V2, V3 values are given, can we find this V average? Note down this. I will do the LCM part here. First question will be given like this. Not diagram won't be mentioned. Diagram won't be given. Just they will ask. First half of the distance he covered with the speed V1, and next half distance is divided into two equal time intervals. And in first time interval he travelled with the speed V2, and second time interval he travelled with the speed V3. Now what is the average speed? Original formula will never change. Original formula is total distance by total time. Total distance is 2S only, na? And here it is S by V1. And here how we can write? First of all calculate T. What is T? That T you have to substitute here. And this S part of the distance is V2 into T plus V3 into T. So that I am substituted here. Note down this. So LCM part I will do here. V average. So V average is equal to, what is the LCM here? V1 into V2 plus V3. That is the LCM in the denominator. Okay, denominator. V2 plus V3 plus 2V1. 2 divided by, this will go up, 2 into V1 into V2 plus V3 divided by V2 plus V3 plus 2V1. So that is the answer, okay? Note down this. question. A body covered s distance with speed v1 and remaining s distance with speeds v2 and v3 in equal time intervals, then find V average speed. That is the question, okay? When you are given the question, just draw the diagram, then you will get some idea. Okay? Note down this. This is the ending of this question. This is the starting thing. Just we substituted the t value there, and then this is the final thing. Original formula is Maradamma. What is the original formula? Total distance by total time. That will not change. You may get special case 1, special case 2. You may get like that. The original formula will never change, okay? Right, I'll erase this. Okay. So we'll go for the acceleration part. You can apply the same formulas for average velocity, but instead of distance, what you have to take? Displacement, total displacement by total time. Okay. So this I am erasing. Okay. Uday Charpecha.
Okay, sir, finished.
Okay, very good. Right. Just start this one. Right, so we'll go for the acceleration part. Accelerate, increasing the speed. God has given us this facility. You can accelerate. What is that acceleration? For bike, you have to do like this. For four-wheelers, you have the accelerator near your leg. Okay, you know that all the three which are there, all the three controls in a four-wheeler. A, B, C we call accelerator, brake, and clutch. Okay, that is a different thing. Okay, central one is the brake. Right. So acceleration means it is velocity of the vehicle is changing. Velocity of the vehicle, if it is changing, we call the vehicle is accelerating. Again, there are two types of accelerations. One is average acceleration and the second one is instantaneous acceleration. So first we'll go with average acceleration. Average acceleration is change in velocity by time. Like this you can write change in velocity divided by time interval. Time interval. Okay, this is average acceleration. And second one is instantaneous acceleration. Acceleration at that particular instant of time. Instantaneous acceleration. I have to write it like this, dv bar by dt. Rate of change of velocity, I have to say. This is nothing but rate of change of velocity. What is the unit? Meter per second divided by seconds. Units are meter per second square. Meter per second divided by second. Meter per second square. Note down this. Average acceleration, instantaneous acceleration. So there is a possibility that we have non-uniform acceleration. We have the best example for uniform acceleration as acceleration due to gravity. Earth will be pulling us towards its center. So Earth will be pulling all of us towards its center, and even all this pen and everything, it will be pulling towards its center with an acceleration 9.8 meter per second square. That is constant. Okay. And if I leave this pen and a duster from the same height, okay, from the same height, if I leave, both will touch the ground at the same time. So that acceleration due to gravity is independent of mass. And what is the best example for uniform acceleration? Acceleration due to gravity. When a body is falling under gravity. 9.8 9.8 meter per second square. Okay. In general, we have non-uniform acceleration. Sometimes we accelerate, sometimes we maintain constant speed. Constant acceleration we cannot maintain because we may hit somebody or some wall. Constantly the speed is increasing, we cannot maintain that, okay? But there is an example for uniform acceleration. What is that? Acceleration due to gravity. So then you have written this. Instantaneous acceleration is dv bar by dt. So then we can have the accelerations as can also be classified as uniform and non-uniform accelerations. Acceleration can also be classified like this. This I will erase. Okay. That there we'll write the example of uniform acceleration. This okay. Fast acceleration can also be divided like this: uniform acceleration and non-uniform acceleration. Example: what is the example of uniform acceleration? Acceleration due to gravity. We are all stuck because of this force, gravitational force. Right. Acceleration due to gravity. Earth is a very massive thing, and it is exerting a lot of force on us. Lot of force. And what is non-uniform acceleration? What is the second kind? Non-uniform acceleration. This example, any vehicle when it is moving from one point to the other point, it cannot maintain uniform acceleration because its velocity keeps on increasing. It is not possible. Okay. So this is uniform acceleration in day-to-day life. When we go on some vehicle, it's not possible. But this is possible, non-uniform acceleration. Okay, acceleration is not constant. Non-uniform acceleration ante intama acceleration is not constant. So we'll go with the remaining topic tomorrow. If a body is traveling with uniform acceleration, we have 3 equations of motion. V is equal to u plus at, s equal to ut plus half it. So that we'll go tomorrow and we'll do the problems on that also. Okay, bye everybody, take care. Bye.
Bye, sir.
Bye.